Welcome to practical session 9 for COMP389 589. Today you're actually going to be working on practical assignment number 2, and I've just created this prac just to give you a few quick pointers on what you should be looking at and what you should be doing. So the reading for this one is of course the assignment description, which is practical assignment, which is the assignment, and also practical session, lab session number 4 has some stuff in there about building data-driven applications, and of course practical assignment 2, which is the assignment description. So just before we get started here, so your task for practical assignment 2 is actually to construct a database-driven address book application using Java and PostgreSQL. So you'll basically be building the database schema for your address book that you'll design yourself, and then you'll be implementing a command line driven Java program that actually allows users to enter in data, to search for contacts, and also edit them. So basically here we outline the data that your schema will need to contain. So you'll have some basic contact information. You'll have email addresses, so each contact can have 0 or more email addresses, contacts can have 0 or more phone numbers, and contacts can have 0 or more addresses actually assigned to them. And then we've got the actual functionality. So your Java application will have to have a search facility, so they can actually search based upon first name, last name, or serial number, a facility to add new contacts, a facility to edit existing contacts, the ability to delete existing contacts, and the ability to generate a list of all of the contacts in the database. So those particular functionalities should be implemented using a menu-driven system within a command line interface. So the root interface, or the first interface, should look something like what we've got here, and your other interfaces should follow on with a similar format, prompting the user for various items of data. Now, you should be using the JDBC libraries and the driver to connect your Java application up to the Postgres database. Remember that when we're building data-driven applications, you'll be using your apps database that we looked at first back in practical number 4. Now, to implement your database, you need to construct your schema, so remember to think about things like the foreign key constraints, so primary key and foreign keys, and also think about the referentially triggered actions, so what happens if you delete a contact, for example, what should happen to all of the addresses in other tables that you may have them in, should they be deleted, updated, etc. And you should be using appropriate data types for them, and you've got a little marking scheme here that outlines how everything should, how the marks will be distributed across the assignment. So if we jump back to today's practical session, so the first thing to do when we're starting this assignment is actually to go and complete or review practical session number 4. So practical session number 4 covered off on building data-driven applications using Java, the JDBC driver, and connecting them up to Postgres. So make sure you get your apps database working, and connecting up to that one, and then go through this prac. And there's actually some solutions for this prac available. If we go back to week 4's practical, I've uploaded a set of solutions here, week 3's practical rather, for you to go and grab. So they're the files that contain the solutions for the three exercises that you've got to complete in that particular practical session. So make sure you cover off on those items. So the starting point for this assignment should be the database schema. So review the requirements, so the data that each item needs to contain, or that you need to store in your database, and come up with your schema. So draw it up as an entity relationship diagram first, and then refine it into a third normal form schema. So all of your schemas should be in third normal form. If I see something that's not in third normal form, or you've got inefficiencies there, so you've got redundant data and things like that in your schema, or a schema that's conducive to those type of faults that we covered off on, then I'll be deducting marks. So another point here, just a little implementation tip, recall that your contact should have a unique serial number. Now, implementing a unique serial number in Postgres is really, really simple, because Postgres provides the serial data type. And the serial data type is an auto-incrementing numeric value. So it's actually an integer value that increments every time you add a record to the database. So if we create a simple table here called table name in this particular example, and we create a serial type value, when we insert records in, we actually just leave this column out of our column list that we want to insert values into. So in this situation, we're leaving col name out. We're only putting other col in our insert list, and we're inserting values for those. The Postgres database management system will automatically populate the col name column with the auto-incremented number there. So it maintains a sequence in the background and actually updates it and inserts it into that particular column every time you enter a value, every time you create a record but don't specify that col name attribute be populated here. So just recall these, so make sure you review this example, because it'll allow you to easily create an auto-incrementing serial number for your assignment without needing to rely on your application, your Java application, for doing that. You can actually return a serial number for an item that you've created using the returning clause. So here we have our insert function, our insert calls again. You can see here it's exactly the same as what we had before. But in this example, we've got the returning clause at the end, and it returns col name, which is our auto-incrementing serial here. So when we carry that when we execute that SQL statement, it'll actually return the serial numbers for us, the col name values, and we can actually grab hold of them in our Java application. And if we need to use the serial number for any reason back in our data-driven Java application. So that's just a nice little tip there that I thought I'd throw in so that you can to teach you how to create your own auto-incrementing serial numbers in a data-driven application. Your Java program can access your serial numbers through the returning clause there. So once your schema is up and running and you're happy that you've got all of your tables created, you've got things like foreign keys declared, referentially triggered actions in there, and any validation items that you might want to put in there. So if you want to put any check clauses in there, should get those in as well. Once you've got all that in place, you can then actually connect your Java application up. So start out with the basics, get your application connecting and reading data from your contacts table. So you might need to insert some dummy records in there using the PSQL client program. Then move on to actually get it creating new records, and then get the menus all straightened out. So once you've got that all working, you should be able to create some reusable functions for inserting items into your database. So I want to see a nice library of code being built up there. You can have as many objects in your solution as you require. You're not restricted by the number of files that you could have there. So I'd expect to see a couple of different files, potentially have one file for your application, and then maybe create a database helper class that contains all of your database interaction functions in there. So remember that your program should prompt the user for connection information when you start the program up. So there's no need to hard code any of your connection details. So recall from Practical 4 that when we connect up to our Java database, we have to specify a connection string. So we do that in our get connection function. Here, we also have to specify the database name in the URL. This information the user should be prompted to supply the database name, the username, and the password when your program starts up, so that there's no need to hard code those items in. So make sure you get that all up and working, and make sure you have lots of internal documentation, so lots of commenting in your code. We want to have everything tabbed and presented in a consistent way as well, so it'll be nice and pretty. Lots of internal documentation, so that if somebody else picks up your code to edit it or read it, they can instantly understand what's going on in there. So really that covers off on our quick look at assignment 2. So you've got today's practical session to work on that one. If you have any questions about the second assignment, send them through. And if you have any problems connecting up to your apps database as outlined in the housekeeping section of Practical 4, please send them through and get that running as quickly as possible. So if there are any issues with your apps account, we can rectify those and get it working as soon as possible. So thanks for tuning in, guys, and if you have any questions, send them through.